So in this video, we're going to be finding the height of a mountain. So application of the law of sines video. So to measure the height of a mountain, a surveyor takes two sightings of the peak at a distance of 900 meters apart on a direct line to the mountain. Okay, so what does that look like? So you got the surveyor. So they're looking to the top of a mountain. So you got your little mountain here. All right. So we got one view right here. And maybe, the height of the person is 2 meters. And then they walk 900 meters. This is obviously not drawn to scale. And then they view the angle again. So that first angle was an angle of elevation of 35 degrees. That second view was an angle of elevation of 47 degrees. Okay. Now, if a transit is 2 meters high, so we're 2 meters off the ground, what is the height of the mountain? Okay, so the height of the mountain. All right. So we want to know, how high is that mountain there? Okay. So how do we do it? Well, break down my triangle here. Okay, this is a right angle. All right, so let's call this side B. Let's call this little c. So this is angle big C. This angle here is 35 degrees. This angle here is 47 degrees. Okay. What do I know about a straight angle? It's 180 degrees. So that means angle C is 180 minus 47, which is 133 degrees. Okay. That also tells me angle A here, which I know this to be 900 meters for that distance there. So if this is equal to 133 and that's 35, to get this angle A, I do 180 minus 133 minus 35. And let's see here. 180 minus 133 minus 35 gets me 12 degrees for that angle. So if I have the sine of angle A over little a equals the sine of angle C over little c, then I can figure out this hypotenuse C for that right triangle, and then I'll be one step closer to getting my B. So the sine of A, the sine of 12 degrees over little a, 900, equals the sine of C, the sine of 133 over little c. And then so that tells me that C is equal to 900 times the sine of 133 over the sine of 12, which is roughly 3,165.86 meters. Okay. So that's my C, 3165.86. Now, I need this side right here. Well, what do I know? Okay, I know that the sine of 35 degrees is equal to opposite over a hypotenuse. So that's going to be b over 3165.86. So now that tells me what b is if I multiply through. B is equal to 3165.86 times the sine of 35 degrees. Type that in my calculator. I get 1815.86 meters. So if I round to the nearest meter, that's 1816 meters. Okay. And that's all there is to it. The height from the peak, okay? Remember, that's this height right here, but we also have to add in the 2 meters for how tall the measurement was. So I need to add 2 meters, and then I get 1818 meters from ground level to the peak. Okay? All right, let's do one more. So we've got rescue at sea. So the rescue at sea. Coast Guard Station Zulu is located 120 miles due west of Station X-Ray. A ship at sea sends an SOS call that is received by each station. The call to Station Zulu indicates the bearing of the ship from Zulu is north 40 degrees east. So that's 40 degrees east of north. The call to the station X-Ray indicates that the bearing of the ship from X-Ray is north 30 degrees west. So we go 30 degrees west of north. So the question is, how far is each ship or each station from the ship? So let's draw a picture. So we've got north, south, east, and west. Okay. So we've got the Zulu operation, and we've got the X-ray broadcaster going out. And so the ship, all right, look at that great ship, right? Okay. So the ship is out in the ocean. So, you know, here's the ocean. Right? Look at all that purple water. Okay. So what are we doing? We're going from here to here to here. Okay. Now, the distance between Zulu and the station, or the X-ray station, this is 120 miles. Okay. Now, a ship at sea sends the SOS call to each station. The call to the station Zulu indicates that it was northeast. Okay, so northeast, so north, and then east by how many degrees? Well, it was a bearing from Zulu of north 40 degrees east, so that's 40 degrees here. And then the X-ray station received it at north 30 degrees west. So looking west, that's 30 degrees to the west, like this. Okay. And so what does that tell me? That tells me that this angle inside here is going to be 50 degrees because it's got to add up to 90. And this angle here is going to be 60 degrees. Now, if that's the case, what do we know? 180 for how many degrees in a full triangle? 180 degrees minus 50 degrees minus 60 degrees equals, well, 70 degrees here. 70 degrees. Okay. Now let's use our trigonometry. So let's call this angle C. So that means this is a little side C. Let's call this A, so that's capital A. And then this B, and so that's the little b here. Okay? So how far is each station from the ship? So we need to find, so how far is each station from the ship? So we need to find A and B. That's what we're looking for, how far we are from each ship, okay? Or the ship from the Zulu versus the X-ray. All right, so the sine of capital A over little a, okay, equals the sine of big C over little c. So that tells me the sine of 50 degrees over little a equals the sine of 70 degrees over 120. So that gets me A equals 120 sine 50 degrees over sine 70 degrees. Okay, if I type that in my calculator, I get 97.82. So that's how many miles it is here, so 97.82. And then for B, I do the sine of capital B over little b equals the sine of C over little c. And so that's the sine of 60 degrees over little b equals the sine of 70 degrees over 120. And so I get B equals 120 sine 60 over sine 70, which is roughly 110.59 miles. 110.59. Okay. The next question is, if a helicopter cable of flying 200 is capable of flying 200 miles per hour, is dispatched from the nearest station to the ship, how long will it take to reach the ship? Okay. So B, the helicopter can fly 200 miles per hour. It's pretty fast, right? And it's coming from the nearest one. So if it's coming from the nearest one, the station, the X-ray station is the nearest one. So nearest station is equal to X-ray, which is 97.82 miles. Okay. How long will it take to reach? Well, the time t needed for the helicopter to reach the ship from the station X-ray is found by distance, which is, in our case, the distance is this distance right here, which is A, which is equal to the rate times the time. So the rate, R, times the time, T. Okay, so the question is, how long will it take? So we want to know T. So how do I solve for time? Time is equal to A divided by R. Now A divided by R, the distance, 97.82 miles, divided by the rate, 200 miles per hour, which is equal to 97.82 miles over 1 times 1 hour over 200 miles. Keep change flip. And so when I type that in, I get 0.49 hours, or roughly 29 minutes. Okay? So it'd take the helicopter about 29 minutes to come out and rescue the ship.